So we continue our journey up the cosmological distance ladder, and this time it's redshift. Hi everyone, I'm Ed, one of the astronomers at the Royal Observatory Greenwich. Previously, we've looked at parallax and standard candles to find out the distances to astronomical objects. In the early 20th century, astronomers making measurements of light in distant galaxies noted something interesting. Now, the wavelength of light itself can change. It can be decreased, that's known as blue shifting, or increased, known as red shifting, and that was what was being seen here. But it wasn't because of the random motion of stars in those galaxies. There was a pattern, there was a correlation. The further away the galaxy, the greater the redshift seen. Why? Because space itself is expanding, increasing the separation of sources faster the more distant they are, even if that object itself isn't moving on a local scale. What I'm saying is that space-time is stretching. It's quite a hard thing to imagine, but actually the key here for us is to think about it the other way around. Having established this pattern, and we have surveys of millions of galaxies showing that it holds, the redshift of a distant galaxy lets you know how far away it is. And this is phenomenally useful. We can look at astronomical sources far beyond the distance that we could measure parallax at, or devoid of standard candles. We're talking gigalight years. And, in that slightly confusing way that astronomers sometimes do, we can relate the expansion of the universe and the redshift of something to the age of the thing. So we have redshift measurements of galaxies telling us that they were around roughly 400 million years after the Big Bang, which sounds like a lot, but these are at astonishing distances, and they give us insights into the conditions of the pretty early universe itself. Perhaps the ultimate redshift observation is the cosmic microwave background radiation. That's almost 13.8 billion years old. That's around 400,000 years after the Big Bang itself, which, relatively speaking, that's almost no time at all. Now, as a last word of caution, I do want to say that there are other influences that cause redshift, so the overall picture is slightly more complicated. However, by accounting for the expansion of the universe itself, it is safe to say that our distance ladder now stretches very far indeed.